Okay, so now we're going through tutorial 6 and this is question 1. So let's read the question. So there are two rotating rods connected by the slider block P. The rod attached at point A rotates at a constant clockwise angular velocity omega A. Assuming B is 200 mm, which is here, 200 mm, omega A is 6 radians per second. Determine for the position shown the angular velocity of the rod attached at B, so basically rod EB, and the relative velocity of the slider block P respect to this rod. Okay, as usual, we'll write down what we know first. We know that this angular velocity of A, omega A, of 6 radians per second is actually negative 6 radians per second. Why? Because it's rotating at a constant clockwise angular velocity. Clockwise is negative, counterclockwise is positive. That's why we know it's negative 6. That's why over here I know that velocity of P can be determined either from point A or point B, but I take point A first, okay? So for point A, we know that velocity P is omega P from A cross with RP from A. Omega P from A we know is negative 6, so that's no problem. Then we just need to know what's RP from A. We know what's the angle, that's 120 degrees. Why? Because there's 60 degrees over here, meaning to say over here has to be 120 degrees. Okay, so we don't know what's the value. So how can we find this? Through using sine rule. Because this is a non-right angle triangle, we are able to use sine rule. So sine 20 degrees, which is here, over the length RP from A equals to sine 40 degrees here over the length 200. How I know this is 40 is just 180 minus 120 minus 20 degrees. Okay, so very simply I find RP from A is 106.418, and then I put in my unknowns, and I know that velocity at P is equal to negative 638.507 in the 210 degree. Okay, so this is the first equation. Now let's take another let's form another equation so we can solve for these unknowns. So what I'll do is I'll do a body attached frame onto rod EB. So this is my attached frame, body attached frame. And what do I mean by body attached frame? What I mean is this frame would rotate and translate along with this rod. So as this rod is rotating, the frame will rotate as well. And what will this measure? Just the linear movement of point P. Okay, that's why I have VP equals to VP from frame plus VP prime. VP prime is just the entrained velocity. I know that VP from frame is in the 160 degree direction. I do not know the magnitude, but I know what's the direction. Here, measured from the positive x-axis to VP, that is 160 degrees. That's why there's 160 degrees over here. Plus omega P prime from B. I do not know what's the value, but I know but I don't need to know the value for now because I'm trying to find it out over here. The angular velocity of the rod attached at B, okay? Cross with RB prime from B. So I'm going to find the distance from here to here. I know what's the direction. It's also 160 degrees, okay? Using sine rule, I can very easily find what's P pi from B. Just look at the working. And then with that, I can put in all my unknowns, okay? So over here, VP can be equals to this equation over here. So I name this equation 2. Then I'll combine equation 1 and equation 2. So this equation would equal to this equation. So this I brought over to the left side, and this I brought over to the right side. With this, I have one vector equation and two unknowns. One vector equation can be resolved into scalar equation. So with this, we can find the two unknowns. So to find omega P prime from B, I just do dot product 250 degrees for both sides, and then very simply I can remove VP from frame, and I can find omega P prime from B end up being negative 1.8152 radian per second in the K direction. Okay, and this is also same as omega B. Okay, dot product 160 degrees for both sides in equation 3 over here to find what's VP from frame to get rid, and then we can very easily get rid of omega. So Very simply, I know that VP from frame is negative 410.424. The direction we already established over here, so that be in a 160 degree direction. So that's how you do question 1.